Guys, usually when I tell you a page number, a great clue is that I typically will write it up on the board, so you don't have to continuously ask me. I would say ask someone near you, right? So here's the deal. This is something that we have kind of done already. Kinley, will you just put that on the floor so it doesn't go crashing? I'm not sure what is happening back there. Hey guys, we are really riled up. We need to take a deep breath and get it together. Thank you. Okay, so your marking period grade is what it is unless you need to fix some things. So I think a couple of you might need to fix or finish or whatever. We'll talk about that shortly, but I want to get you some notes. Okay. So this is page 135. This is something that you should know how to do. I know a lot of you have used partial sums, but since a lot of you are not able to successfully get the correct answer, we're going to do it this way. Question, Avery. Ben, please move. I don't think this is gonna help, but I will close it. I think it's the other one. Is that better?
It helps me a lot.
Perfect. All right. So when one number is divided by another, the result is called a quotient. So our result up here is a quotient. Quotient. And the word is right on your paper if it's easier for you to copy down from here. That's where we're putting it. The dividend is the number that is divided. So this 240 here is the dividend. And the divisor is the number used to divide the dividend. Divisor. So if we saw 240 divided by 8, this is how we would set it up, right? So here we're seeing this number divided by that. That divisor is what's going to go on the outside. They're giving us a lot of this for us. That's what's nice and what's not nice about this packet. So you gotta stay focused even though you don't have to write something down.
So the one on the right side will be plus 5.
Yes, the second number is what goes on the outside of that division symbol. Good question. Question, SJ. Then go to the bathroom or go to the office. Somebody used the last of my tissues. What's up? Are we gonna do this every day? You mean math? Are we gonna do math every day? Likely? I don't know. So here's the deal. This is what happened first. They ask, how many times can 12 go into 25? They said 2. Notice they put that 2 above the 5, right? And then they said 2 times 12 is what? Guys, they wrote it for us, 24. So they subtracted 24 from 25 and they got what? 1. And then they brought down the 7. You can draw this arrow here if you're not sure where that 7 came from. So then they asked, how many times can 12 go into 17? That answer was 1. They said 1 times 12 is 12. So they subtracted the 12. 17 minus 12 is 5, right? Then they brought down the 4. And they said, how many times can 12 go into 54 without going over? Good. 4 times 12 is what? 48. So we subtracted 48 from the 54 and got 6. Then they brought down the 0 and said 12 times what is 60? 5. Do you see how they got the answer? It's kind of a lengthy process, but if you know your basic multiplication facts, you can do this. Okay? How can you check to see if the quotient is correct? We would say 2145 times 12. This is fantastic practice for you. Some of you are still not doing this properly. What do I do first? 2 times 5 is what? 10, so I have to carry the 1. 2 times 4, plus that 1. Very good. 2 times 1, 2, and 2 times 2, 4. What do I have to do before I start multiplying by 1? Put a 0 here, because I'm really multiplying by 10, right? And then I'm just going to copy these backwards, because 1 times 5 is 5, 1 times 4 is 4, 1 times 1 is 1, and 1 times 2 is 2. So I'm adding these up, and I have 0. 9 plus 4, I'm sorry, 9 plus 5 is 14. 4, 6, 7, 4, 5, and 2. Did it equal this? Yes, it did. So this is how we would check to see if we were correct. All right? Essentially, when we're dividing by something, we're asking what times this number equals this. So what times 12 equals 25,740? 12 times this, 2145. Do you see how division is backwards? It's kind of the opposite, the inverse operation, you will soon see. All right, so here comes the tricky part, us trying it on our own. We're going to write a 35 on the outside. And then inside my division symbol, I have 5, 2, 4, 2, 8. Write this down and start to see what you would do next. This is the next page, so this is page 136. $34 doesn't go into 5, so you're saying how many times can 34 go into 52? All right, I have seen this. 34 times 1 is 34. This is as close as we can get without going over, right? Can I say that 2 minus 4 is 2? No, I have to borrow from the 5. It becomes a 4. So what is 12 minus 4? 8. And then I'm bringing down the 1. 4 minus 3 is 1. All right, guys, here's where it gets tricky, and we have to kind of guess and check here, because what do I do next? Good. Because I wrote the 1 above the 2 where I needed it to be, I know I'm bringing this next number down, which is a 4. So when I start thinking in my head, I'm estimating this as 30 and this has 180. So 3 times what would give me 18? What? 6. 3 times 6 would give me 18. Hey guys, if you don't know these facts, you need to know them. I literally just asked what times 3 equals 18. So listen listen, focus. So 3 times 6 does equal 18, but I noticed that if I multiply that 4, this is gonna be way more, so I'm gonna go down 1. So I'm going to multiply by 5 to check 5, to see if we can get close without going over. What's 5 times 4? 20. What's 5 times 3? 15, 16, 17, right? As I'm estimating, if I add this to it, it's gonna be way over that. So I'm gonna go with 5. So I'm putting the 5 above the 4. We know that 5 times 34, we just did it, was 170, right? So now I'm subtracting 4 minus 0, 8 minus 7, and then that becomes 0, right? You got it. Now I've got to bring down the 2. And I'm going to do this similarly. 3 times what is 14? Without going over. 6 is 18. 5 is 15, so that's probably too much, right? So 4. So if I said 34 times 4, let's see where we end up. 4 times 4 is 16. 4 times 3 is 12, plus 1 more is 13. I don't think I can add another 34 to that without going over that. So I'm going to say 4. And I just said 4 times 34 is 136. Can I say this is 4? No, I have to borrow from the 4. It becomes a 3. What's 12 minus 6? 6. If 12 minus 6 is 6, this is all 0, so now what do I do? Bring it down. 34 times what is 68? 2. And it's even, right? So minus 68 here, we're done. El Dunzo. It's kind of a long process. Can we do it? Yes. Is it gonna take some work and effort and thinking and following that process over and over? Yes. Will it probably take practice? Yes. All right. So when we don't end up with a nice even divisible number, right? Divisible means it can be divided without a remainder. When we don't have that, sometimes we have remainders. So here they said 25 goes into 82 3 times. 3 times 25 is 75, so they subtracted the 75. 82 minus 75 is 7. Then they brought the 0 down. So 25 can only go into the 72 times, which is 50. So 70 minus 50 is 20. So I have a remainder of 20. If we carried on and added a decimal, we can add as many zeros as we want, right? If I have $5, I could add as many zeros to the end of after my decimal, and it's not going to change my $5, right? It's always going to be $5. Would you agree? I can add zeros after decimals without adding anything, not changing my number. So that's what they did here. And look what happened. They brought the decimal up, and then they brought down another 0. Once we had 200, once that 20 turned into 200, we were able to say 25, well, how many quarters is that to be $2? 8. And then it went in evenly. You see how we're gonna end up with a decimal? So you know, and you told me you knew you've seen this, you can write the remainder as a fraction? And doesn't, if we simplify this, wouldn't we have 8/10? 20/25? We multiply the top and the bottom by 4, we would have 80/100. 80/100 is equal to 80/100, which is really, we don't need the 0, 8/10, right? So you could write it as a remainder or as a decimal or as a fraction. So I think they're asking you now, to continue on. So you have this big long decimal. So we have to know the process, right? 64 couldn't go into 5, it couldn't go into 52, but it could go into 527. And that got pretty ugly, right? So you might be thinking 6 into 52. I don't know. They decided they could do that 8 times without going over, and 8 times 64 gave them 512. SJ, with me?
Yeah.
Okay, stay with me. This is page 137. We've only moved on one page. So we have 8 times 64 is 512. The difference there is 15, and then they brought down the 2. So 64 could only go into that 2 times, which was 128. When we found the difference there, the difference was 24. And then we had a bunch of remainders. So they added a decimal and a 0. They brought down the 0. We still couldn't quite go. So 3 times 64 was 192. So then they found the difference of 48. Then guess what? We brought down another 0. 7 times 64 was 448, which gave us the difference of 32. So we brought down another 0, and finally 64 went into 320 evenly 5 times. So that was a lot. Do you see how they brought down these things? Once they didn't have anything to bring down, they added a decimal. That decimal, Vinny, went straight up into our answer, right? And then these zeros, we can pull down as many zeros as we need to. 0 the hero here, okay? So our answer here is this. Remember, this thing up on top is our answer. That's important to remember as well. So that is 82,300. Oh, that's not a comma. What is it? It's a decimal. So it's 82, and remember we say and for our decimal. 375 tenths, hundredths, thousandths. Bravo. Tenths, hundredths, thousandths. Yeah, I said bravo. No. 375 thousandths. You're right. All right, so we've got to do some estimating. We've got to add a decimal into our, what do we call that number inside? Our dividend. We got to add a decimal to our dividend. So 60 into 16047. Guys, I'm not going to put the comma in here because I don't want it to get confused with my decimal like I almost did before. Okay? So when you're starting off thinking 60 doesn't go into 1, it doesn't go into 16, but it should go into 160. So our first quotient, part of our quotient is going to go right here above the 0. What's going to go here? How many times can 60 go into 160 without going over? Not 3 times, that'd be way too much, that'd be 180, only twice, yep. So put a 2 above the 0. 2 times 60 is what? 120, so what are we subtracting from 160? 120, all right, keep going. Alright, so let's keep working this. We said 60 times 2 is 120, so I'm subtracting it from 160. 40, good. And I would bring down the 4. So I'm kind of thinking, how many times can 6 go into 40 without going over? Just 6 times, right? 6 times 60 is 360. So this is 4, we have to borrow here. This is a 44. Bring down the 7. How many times can 6 go into 447 without going over? Hopefully you said 7 times, because 7 times 6 is 42. So this is 7 and 2. Now what can I do? I can add a decimal, but remember, if I add a decimal here, I also need to bring it up to my answer. And I can add as many zeros as I need to. So if I take it into 270, how many times can 6 go into 27 without going over? It's something we gotta know. 4, yep. 4 times 60 is 240. So this is 30. And now we see that when we bring another 0 down, how many times can 6 go into 30? 5 times. And this is even, right? Because 5 times 60 is 300. So here is how we would show that decimal answer. All right, so I just gave you a packet. Make sure, oops, sorry. Make sure your name is on it. Do not shut your journal because this packet needs to go in. So if you shut your packet, turn now to page 141. Notice they give us room here. We don't have a ton of room here, but this is what you're going to turn in, so you can show your work here and then turn this in here. Do you see what we're doing? What do you mean no? So try these 3. Once you get these 3 done, you can work in Alex. We're editing these shortly. So we're going to say 15 into 52080. We're asking 15 times what is 52? If you're not good at multiplying, start adding them. I know 15. Then another 15 would be 30. Then another 15 would be 45. If I add any more, I'm going over. Question, Kinley. This is page 141. And page 1 in your packet. So we just said this would be 3, right? And we said 3 times 15 is 45. So now, guys, it's very important that you know how to subtract. If you can't subtract, you can't divide. You can't add, you can't multiply. All the things, guys. We got to be able to do all the things. So I'm going to borrow. 12 minus 5 is 7. I would bring this down. So if it helps you, start listing your factors of 15. We said 15, we said 30, we said 45. If I add 15 to that, I'm at 60, then 75. Notice here, how many times can 15 go into 70 without going over? Only 4 times. This is 1, 2, 3, 4 times. So I would subtract 60 here. Even this doesn't give us a ton of room. If I add 15 here, I'm at 90. If I add another 15, I'm at 105. So this is 1, 2, 3, 4, 5, 6, 7 times is 105. I'm subtracting 105. Oh, we need like extra paper here, don't we? Good, so this is 3. I would bring down this 0. How many times can 15 go into 30? 2 times. And this one's even, right? When I subtract 30 here, I do not have a remainder. So if you are someone who struggles with their handwriting, definitely grab a notebook and do it on some lined paper, or grab a piece of unlined paper if you prefer. I think lined helps though. And so I'm gonna put my answer here. 3, 4, 7, 2. There's no decimal. Yes, you're going to get decimals for these. Some of them might have decimals. Here, we're gonna start adding decimals next. All right, so try number 2 and 3. Work in Alex. Remember, these are extra days for Alex in case you don't have your 25 yet. I'll get with you that need to finish the quiz.